So at the end of the last video, I said we would close out our discussion of the Gothic with one failure and one modest and complicated success that nicely bookmarked the sort of end of the Gothic and set us up for what comes next. The failure is also the tallest of the Gothic cathedrals and one that's actually incomplete. Beauvais, as you can see, done in the 13th century, was intended by the town to outdo all the rest of the cathedrals. And as we said, they had not only a religious function, but clearly a political and civic one as well. In other words, every town wanted to be the tallest, to be the biggest, and Beauvais was no exception. And if you look at the section and at the proportions, you can see that it was ambitious. It not only would have been the tallest, but also to have the slenderest structure. And thus it would have been the ultimate example of light and height, right? The ideals of the Gothic. And in fact, it is incredibly impressive, at least what there is of it. The first building campaign, begun in 1225, constructed the choir. And you may notice, if you've been taking notes, that the choir of Beauvais, even though it's a 13th century cathedral, has sexpartite vaulting. In other words, there are 6 vaults in each structural bay. And we remarked that High Gothic was notable for the fact that it switched to quadripartite vaulting, 4 vaults per bay, structurally more rational and architecturally more coherent. So what happened? Well, if you look in the lower story of the photo on the right, you can see traces of an arch that spans the whole structural bay. In other words, where there are 2 arches, you can see a trace where there was originally 1. And that is because the choir had to be largely reconstructed after it collapsed. So what happened in 1284 to cause the collapse? We know that the vaults came down in a windstorm, and a lot of speculation has looked at the slenderness of the vertical buttresses and their position as a potential cause. Viollet-le-Duc, the 19th century theorist, thought that the middle pinnacle was the problem. He pointed out that it comes to rest in the middle of the vault below, not directly over the vertical support. He thought this might have created a shear problem. And this may have been one of the things that medieval builders sought to correct when they came back and installed more verticals to take more of the load away from the vertical buttresses on the exterior. Robert Mark, who has several readings this week, did his own analysis using plastic and polarized light to show where the stress concentrations would occur at their greatest in a windstorm. And he pointed out that this middle pinnacle and its intersection with the vaults below did in fact have some of the highest compressive stress in the building. Jacques Hyman, though, the great structural engineer, sort of forensic engineer of the Gothic era, points out a couple of things, though. One, the stone was nowhere near its compressive limit, right? There's a margin of safety in terms of compression in Gothic structure that's just enormous. 2, the building had stood for some 60 years before it collapsed. So it couldn't have been settlement, or it couldn't have been a flaw in the design, because the building had already shown that it could safely carry the loads. What Hyman's analysis leads to, and I think what's more probable, is evidenced by the fix that was built on the vertical pinnacles, or the vertical buttresses, after the choir was reconstructed. You can see them today. They are iron straps that connect the pinnacles to one another, not in cross-section, which is what Mark was looking at, what Viollet-le-Duc was looking at, but basically longitudinally, or around the end of the apse. And Hyman points out that these vertical buttresses are incredibly skinny, and it would have been very easy for a big windstorm to bend them out of plane. And when that happened, the thrust of the flying buttresses would be off-center, wouldn't have anything to resist it, and would simply push out, leading the vaults to collapse. Whatever the actual mechanism was, the builders went back, they adjusted their vaulting, which may or may not have been the problem, but seems to have at least safely rebuilt the building. And then they did come back and add the iron straps to the buttresses. That saved the building, which survived, although the appetite for finishing the construction waned considerably. There were a number of factors that led to the sort of close of the Gothic era, but Beauvais' collapse was at least coincident with those. By the 16th century, the crossing had been built, one bay of the nave, not much more, and the town decided that they would commence rebuilding in the 1500s now, starting with the tower, and that proved to be a huge mistake. The tower at Beauvais was one of the tallest structures in the world for a brief period, something like 450 feet. It too collapsed in the late 16th century, and its mechanism of collapse was much more obvious. Without much on the nave to buttress it, the weight of the tower simply pushed that first and second bay, the bays of the nave that had been constructed, simply pushed them out because of the thrust that the vaults holding the tower up put on those structures. With the tower collapse, the city stopped work entirely, thinking that both the design was probably unsafe and that maybe it was just unwise to consider continuing to build. Beauvais stands today as literally just the choir, the apse, the crossing, and the transept. There's no nave to it. It is still an impressive structure, albeit one whose proportions are a little odd. So I said we'd also end with a success, but one that brought with it some issues. And really one of the last buildings of the Gothic era was the cathedral at Milan. Italy was slow to pick up on the Gothic Revolution. The technique spread southward from France, and by the time it hit Italy, it had been through a number of transitions, a number of evolutions. We tend not to think of Italian Gothic as the real peak of the movement. We tend to think of that happening in France and England and sort of trickling out to the rest of Europe. The city fathers of Milan decided to build a cathedral, though, and wanted to do it more or less in the French style at the end of the 14th century, so very late in the Gothic era. They faced a problem, though, which was that they didn't have the expertise in Italy that they did in France. And so by 1391, having laid out a ground plan but not able to agree on a section, they decided that they had to bring in consultants. And the consultants were brought in basically as scientific or engineering consultants to determine the best proportions for the section of the cathedral. Now, on one level, this makes perfect sense, that the thrusts, the equilibrium of the vaults is a complicated mathematical issue involving geometry that would have been beyond the realm of most people. Remember Procopius talking about a cylinder being a sort of exotic architectural or geometrical form in describing the Hagia Sophia. So the way that these vaults interacted was certainly beyond what most people, including the leaders of the city of Milan, would have understood. But interestingly, the person they brought in was first a mathematician, Stornoloco, and he said that the real problem was whether to design it ad quadratum, in other words, using squares and rectangles as the basis for the proportion, or ad triangulum, in other words, using equilateral triangles. And you can see his two options, basically, that he presented on the top, A and B. So all to do with proportion, nothing to do really with the way forces worked as we understand them today. They argued for 5 years and finally went abroad to Paris to bring in an actual Gothic builder to tell them basically the proportions that they had to build with. Jean Mignot, the consultant, basically, that they brought in, outdid himself, finding 54 problems with the design, some of them quite trivial, others of them potentially real, but basically telling the people of Milan that they didn't know what they were doing. And the people of Milan, the local committee, responded in Latin, look, we don't need you to tell us what the building looks like. We just want you to tell us how to make it stand up. And roughly translated, their response is, science is one thing and art is another. Leave the art to us. And Mignot's response, which has come down to us as a sort of aphorism, ars sine scientia nihil est. In other words, art is nothing without science. Now, that to us sounds very modern, right? Sounds like a basis for contemporary engineering. But Jacques Hyman points out that this, in some ways, was actually a sort of symptomatic of the time, and also, as he puts it, kind of an epigram for the end of Gothic construction and the Gothic approach to building science and engineering. Mignot is saying basically that you need a theory, or to us it sounds like he's saying you need a theory, that you have to base your decisions on the architecture of the cathedral on the latest knowledge. But the knowledge that he had was a code of rules, right, developed by guilds, and telling him basically what the ideal proportions were, not from any sense of trial and error or experimentation, but simply from authority, that these are the proportions we've used before, these are the techniques we've used before, these are the techniques that you should use. They were rules of thumb, essentially. And those rules of thumb, as Hyman points out, had been used to build Beauvais. And so they had in a way been disproven for 100 years, that they only extended to a certain height. The issue here was whether to believe authority or whether to gain your knowledge in some other way, and in particular in some other way that was rigorous enough to guarantee the results that you would get. And Hyman points out that the problems of Milan were essentially the death knell for Gothic approaches, that this was not really the last time, but maybe the last time that was published, that this debate between the theory, quote unquote, of the guilds, the rules of thumb, would come up against a quest to find some sort of deeper knowledge. We will start in the next lecture to look at where the roots of that knowledge came from. The Renaissance we think of as an artistic revolution, the revival of Roman forms in particular. But I want to argue that it was also a technological revolution, or it came from a technological revolution, and it produced a subtly new way of thinking about how we know what we know about building, that led to what today we would call the modern science of engineering. Very much in the way that Hyman would define it, and very much in the way that Hyman's summary here of Mignot's response shows the limitations of Gothic, quote-unquote, engineering, while opening the door to something new.